Find real numbers a, b, and c so that the graph of y equals ax squared plus bx plus c contains the following points. So first, I'd recommend that we kind of sketch what's happening in this problem and what they're asking us. They're giving us these 3 points, -1, -2, 1, -4, and 2, 4, and asking that we find a parabola. A parabola would be the y equals ax squared plus bx plus c. So we're trying to find what parabola would pass through these 3 given points. So visually our parabola would look something like this. So we don't know the vertex of the parabola. We're thinking that it should open up based on our rough sketch, but we really don't know anything more than that. We just need to find the equation for this parabola. So what we have been given are coordinates, which means we have x and we have y values. We have 3 sets of them. So we're going to go ahead and take each x and y value and substitute those into our equation y equals ax squared plus bx plus c and see what results. So let's start with the point -1, -2. So our y value is -2. We substitute -2 in place of y. And then we're going to substitute -1 in place of all of our x values. So that would be a times -1 squared plus b times -1 plus c. Let's go ahead and simplify that equation before we move on. So this will give us -2 is equal to a minus b plus c. So we have one equation here with 3 variables, 3 unknowns. So the general rule of thumb is if we have 3 variables, then we're going to need 3 equations in order to solve our system of equations for a, b, and c. So now let's move on to our second coordinate that was given to us, 1, -4. And we'll do the same. We're substituting -4 in place of y. And then in place of all of our x's, we're substituting +1. So that would be a times 1 squared times b times 1 plus c. Go ahead and simplify, and our resulting equation is -4 equals a plus b plus c. So last time with our point 2, 4. Our y value is 4. X value is 2. So a times 2 squared plus b times 2 plus c. And simplifying gives us 4 is equal to 4a plus 2b plus c. So now we have a system of equations with 3 variables, 3 unknowns, and we want to solve for a, b, and c. So we're going to go ahead and do this using elimination. So I've just rewritten our 3 original equations. And first, I recommend that you number them. It's easy to get confused and kind of lost in your own work. So I would recommend numbering your equations, equation 1, 2, and 3, so we always know at all times which equations we're working with. So the idea, since this system is set up nicely for elimination, or the addition method, we want to add 2 of our equations together in hopes of eliminating a variable. So notice if I take equations 1 and 2, I'm ready to do elimination without any work because I have a -b in the first equation and I have a +b in my second equation. So basically the first 2 equations are set up beautifully for elimination. I'm going to go ahead and add the 2 equations together, which will result in -6 is equal to 2a. My b's subtract out, plus 2c. So -6 equals 2a plus 2c. So now, I can't do much else with this equation right now because again it still has 2 variables, but it's better than what I had before. I went from having 3 variables now to just 2. Now notice this equation is in terms of a and c. So now we go back to the original 3 equations and we want to put 2 more equations together and we want to eliminate b. So our options are using equation 2 and 3 and putting those two equations together and eliminating b, or you could use equation 1 with equation 3 and eliminate b. And it's entirely up to you. We will get the same answer in the end regardless of which two equations you choose. Since the top equation already has a negative b, I'm going to go ahead and opt to use equation 1 and equation 3. So if you take a look at equation 1 with equation 3, we have negative 2 equals a minus b plus c, and 4 is equal to 4a plus 2b plus c. So if I want to eliminate b, then I'm going to need to multiply my equation 1, my top equation. I'm going to need to multiply it by positive 2, both the left and the right hand side of this equation. So that means now I'm going to have the equation negative 4 is equal to 2a minus 2b plus 2c. And equation 3 is the same as before. I haven't changed it. And now I'm ready to do elimination, because notice that negative 2b plus 2b will equal 0. So negative 4 plus 4 is going to give me 0. 2a plus 4a is 6a. And 2c plus c is 3c. So put a box around this equation. Here's a second equation, and it has two variables. It's in terms of a and c. So now I'm going to put these two new equations that I've created together and do elimination a third time, because these two equations have the same variables. So I have negative 6 equals 2a plus 2c, and I have 0 is equal to 6a plus 3c. And I'm ready to do elimination yet again. So here I have to choose whether I want to eliminate A or whether I'd rather eliminate C. And I think it'd be simpler to eliminate A, because that would only require that I multiply the equation by negative 3. Both the left and the right will multiply by negative 3. So my new equation is 18 equals negative 6a minus 6c. And my bottom equation stayed the same, 0 equals 6a plus 3c. So now when I do my elimination, my negative 6a and positive 6a subtract out, those equal 0, and I'm left with 18 is equal to negative 3c. So finally I have one equation with one unknown, so I can go ahead and finish solving this time and solve for my variable c. So it looks like c should equal negative 6. So finally I have one of the values of the unknowns I'm looking for. Remember, I was looking for a, b, and c. So now that you have your c value, we're going to do substitution. We'll take our c value and substitute it back. Now, looking all the way back to the original 3 equations at the very top here, I don't want to substitute c back into one of the original equations that I have numbered 1, 2, and 3, because those have 3 variables. So instead, I want to take my c value and I want to substitute it either into my boxed equation 0 equals 6a plus 3c, or my other boxed equation negative 6 equals 2a plus 2c, because those are the two equations that only have 2 variables. So I'm going to go ahead and just choose the second one here, and I'll do my substitution. So the equation was 0 equals 6a plus 3c, but I know that we found c to be negative 6. So I'm substituting negative 6 in for c, and this will let me solve for a. So finishing up with this basic algebra, and it looks like a is equal to 3. So now I have my c value, I have my a value, and now we need to go all the way back to one of my original 3 equations in the system that I created, one of these 3. And we'll substitute A and B both, or excuse me, A and C both back in and solve for B. And again, it doesn't matter which one you choose. I'll go ahead and choose the very top one. So I'm going to choose negative 2 equals A minus B plus C. So negative 2 equals A minus B plus C. We found A to equal 3. We found C to equal negative 6. So finishing our algebra here, and it appears that B should equal negative 1. So the original problem said find the real numbers A, B, and C so that the graph of the parabola would pass through the given points, and we have successfully done that. A should equal 3, B should equal negative 1, and C should equal 6. And if you wanted to go one step further and actually write the equation for that parabola, then our parabola would look like y equals, my leading coefficient is a 3, so that's 3x squared, minus x, because b was equal to negative 1, minus 6. So this would be the curve, the parabola, that fits the 3 points given. Y equals 3x squared minus x minus 6.